Alright, here is a quick look at the motion prediction module used to create a few more interpolated frames that we didn't render and that we might want to actually pick over the ones that were rendered. I'm talking about something like this, where you have a 3D animation. This one created courtesy of Dartenbeck, Carrara user extraordinaire, and also a dog waffle user and beta tester, and he has a lot of experience with rendering 3D spaceships and space scenes. And here's basically the final output. It's not quite perfect. I did this a little bit quickly, but I wanted to show you the steps by which you can perhaps save some rendering time. I don't know, this one was probably not a render that took too long to render. You know, I'm talking about like a scene that might be perhaps an hour per frame, or 5 minutes per frame, and you're doing an animation where you might you might be looking at rendering it for a few hours. And then you notice that you got the almost perfect angle, but just a little bit off, and you'd like to have it, if you zoom in, perhaps you'd like to have a composition in the end where you'll see not this angle, not this one, but something in between. And it's a bit difficult to go back to the rendering and to wait another hour for an extra frame to be rendered just at that perfect angle. So sometimes you can actually get close enough by using the motion prediction module that we have under the filter animated section right here, motion prediction module. Now I'm going to try to recreate the whole sequence of events here, and the way I started was initially by loading a sequence that Dartenbeck sent me. And I'll take the one that's the back view. So we're looking at the exhaust thrusters, the engines, and let's take the whole sequence. I'm actually going to then cut a few off, but we'll be working perhaps only with the middle section, and then we'll making it also a ping pong animation, and then we'll start doing the motion prediction. So let's first load this as an animation. And this image sequence, there it is. It goes, the camera moves from left to right, and so we see a slightly changing angle of the spaceship. And somewhere here in between is where your perfect angle is that you want to really capture, but it's not one that you rendered. Again, this is a sort of a hypothetical scenario where you spend perhaps 5 minutes or 10 minutes or even longer rendering each of these frames, and now you wish you had one that was somewhere between this angle and this angle. And you can use the time stretch to do a sort of a blend, but it's going to be blurry or it's going to be choppy, and it's not the perfect transition. What may be better is to have the motion prediction, give a try with the motion prediction module and see if you can capture that. So to do that, before we do this, actually I wanted to cut it a little bit shorter, show you a few of the frame editing tools as well. So here, let's say we have a few frames at the beginning that we don't care about. So we'll mark this one as the in point, and perhaps this one here as the out marker. And so we have a blue highlighted section here that shows the frames currently selected, sort of a block. You can right click on that, and then you can say delete block. Right, let's do that, and then you can do the same thing on the other end. Let's go to the very end of the animation. There it is, and let's set this one here again, set in marker, and then here set out marker. And so you have that block selected, and you can delete that block. So now you have a shorter animation sequence, and somewhere in between here, let's say first thing you want to do also is make sure that it's not just playing like this, but actually doing ping pong, so it's coming back and forth rather than jumping from the last frame to the first frame. And that we can also do by editing, again, grabbing a copy of this time. Let's go to the last and set the out marker. So we have selected the entire block now. Right click and don't delete this time, say copy block, right? And then we're about to insert it again at the end or at the beginning, but before we do that we want to reverse the ones that's already there. So right click, reverse frames. So now we actually have this one reversed, but the one that we copied is not reversed. So we can go to the beginning and insert it right there. insert block before current frame. So now we have this one, the non-reversed, followed by the reverse sequence, and we end up having this ping pong animation, just like that. Frames per second, let's keep it to where we want it eventually, at 30 frames a second. Now again, this is not the absolute perfect scenario because there's a little bit of noise on here. You can see the anti-aliasing was not very high. There is a little bit of noise, and the motion prediction module might have a bit of trouble at that, but well, let's give it a try anyway. So here's where we go into the motion prediction module. Let's go to the filter, animated motion prediction module. And what we have right now is 29 frames, and we're about to turn that into 3 times as many. Let's first click dry run to experiment with that and say 3 tweens. And let me set it back to kind of where the default values are without refinement pass, and I think it's about this much. This is how far it's searching for. That's the search distance where it's looking for where the tiles have moved, and the grid spacing that shows the tile. Each of those little squares, each of those little blue blocks, let me see that again, there you go. Each of those little blue squares represents an area that's going to be slapped with a motion tracker. So there's a tracking mechanism. A motion prediction module is exactly that. It's tracking the where is it going, where is it moving for each of those little ones. Now this might be roughly where the default, I think it's about 60 or so for the default search distance. I don't recall the exact default value, but when you try it the first time, you'll be there roughly with 1 sample, and I think about 400 for the fudge factor. Right, let's give that a try. Let's go, make sure you have the dry run, and that will turn it into 82 frames. And looks fairly decent, except there's a couple of glitches around here. Let's do that again. Yeah, there's a little bit of noise here that's perhaps confusing it. The patterns are very similar, it might jump. Maybe if we make this a little bit smaller on the search distance, a little bit better. Sometimes what you want to do is keep the fudge factor down or up if there's too much noise, but let's keep it lower. No, that's not the one here. Sometimes you want to have the search distance. Maybe it's moving too fast, and at times you want to adjust the grid spacing and experiment with that a little bit. Let's try this one. Oh, that's better. Look at that. So 15, 101, I don't know if it's the search distance that made it or if it's the grid spacing. Let's try 16, something like that. That's better. Now up here, that looks fairly good. Let's keep an eye on the red lights. Yeah, overall we don't see too much distortion anymore. There's a little bit glitchy 1 or 2 places. Might be better when you do a stochastic average, especially when you have very noisy video. So that might help a little bit. Yeah, we still see a little bit there, but it's not going to be perfect with an image that has noise to begin with. You might do stochastic 15. So it's averaging multiple frames before and after, I think 7 plus the one in the middle, so 15 frames to figure out which one's the best candidate, representing where the blocks have moved as we go and analyze this from frame to frame. So that looks pretty good. Now we might want to make it slower even, so instead of 3 frames, let's say 9. And that means we are now turning this from a 29 frame sequence to 244 frames. And that's really what I'm talking about here. You'll see a greatly improved interpolated animation. There's still a little bit of glitchy here, and we might do a final refinement pass, and that's what we have here when we're done. So let's go stop this and do a refinement pass. Now you could go and make this go for a long time and you know, let's try with just 1, but that's where you can potentially wait a few more extra steps, a few more seconds, but it's often quite worth it, and you'll end up getting a even smoother animation transition. So that's where we're going with this. Let's see if we can perhaps just, let's see if we had this one back at 400. Do we see any artifacts? Keep an eye on the reddish parts here. Yeah, there's a little bit of a ghosting here. I think we'll probably be better off keeping that low. So let's keep this one. That's a high contrast scenario, and that's typically where we want to have it then. Alright, so that's probably going to be our motion prediction module settings. And now comes the time to actually trust it and do away with the dry run. So uncheck that. You know, you got the number of tweens, you got the parameters set here, and go. And so what's going to happen now is it's actually going to render these into a new animation. So it's going to render these and then make that your new animation with the interpolated frame sequence. And it's going to, you know, it's still going to have some edge conditions or some areas where it's not perfect. You might see a little bit of trail, or I call that a wake, sometimes along this area with high speed and high intensity. Obviously, the smoother the animation is to begin with, the better the result is going to be. But and also, if you have topologies that overlap and change, that's always a challenge for motion prediction modules or motion estimation. But it generally speaking, it can give you a shot at another look from different angles that will only take now here. How long have we done this? About 2, 3, 5 minutes maybe. And when you compare that to rendering a very high resolution, high quality image in an image sequence, and if each of them, you know, with global illumination, anti-aliasing pushed to the top, and all sorts of other parameters, it might take 10, 20 minutes per frame. Well, here we've done very much a very smaller, you know, subset of that, and we've created an animation that, for a good part, this part here still has a little glitch when we zoom in, but there's some great benefits to be gained from that. And so that motion prediction module could definitely be something that you may want to experiment with when you have PD Howler with the animation capabilities, to perhaps get yourself into a better choice, sort of a situation where you have more choices to pick, you know, from one frame to the other. You have some frames in between that you can actually choose from as well. And then, of course, this in itself is an animation you might want to perhaps load into a custom brush. Now, this one doesn't have the alpha channel, so you might do that simply with the color keying, and talking about something like this here, where we pick it up as a custom brush, perhaps something like so, and using the alpha the alt key to pick up from the current frame to the last. Oh, and that was not a very smart choice. I should go to the very first here, or maybe not. Maybe I just want to have a little bit of a transition like this. So I'm going to go from about here and capture that like so. And where do we go here? With the alt key, and let go. So now it's picking up this entire remaining sequence from the current frame to the end, because I held the alt key down. It's picking that up and putting that into an animated sequence in the brush now. So I have it here in the main frame, in the main buffer, but I'm also able to pick that up as a custom animator brush. I can store that right here from the brush menu, store, manage, and store and manage this sequence. You can see it as a film strip, so we can see indeed there are multiple frames, and we can navigate through that to kind of get an idea that, yes, that's indeed rotating around, spinning around that entire sequence. But we have an opaque black background here, so let's go right click on the same custom brush selection tool and color key to the black background. It's not perfect because there's a lot of dark spots also inside the spaceship, but it might be good enough for what we need here. So let's go and store that one with the transparency. And now let's see what we do next. Oh yeah, we composite that into some sort of a space scene. So let's say, for instance, we create something new with the animated Starry Night, and in the Starry Night we plunge into the star field, something like this. Star counts, lots of them. Softness, adjust that a little bit, add some glow for the big ones. Speed, and perhaps a little bit to the side, so we have the stars not just coming at us, but a little bit sideways, or not. Okay, let's keep it like this. There's some novas also we can add, a little bit of glow, nova size, gamma, angle, all sorts of parameters to get it exactly where you want it. Add lens flares, that will slow it down a little bit. But we can have a look at what that looks like. These are too big. These stars are too big. So let's go make the star size smaller. There you go. Okay, so let's say we render that. Okay, that. So that's rendering a new animation, and now on top of that we'll have our spaceship dive into that scene. When it's done, still rendering. How many do we have here? 243. Our spaceship is actually on a shorter because we only cut about half of it into the custom brush, so we probably don't need that many. In fact, maybe we want to bring this down to a shorter sequence here with the ghosting. That might be an interesting use of the ghosting filter in the timeline, and so it will kind of create a little bit of a trailing effect. And that's going now through 242. Well, you know what, let's undo that, and instead let's do that first of all creating just half of the, let's use the time stretch to use just half of that with frame blending, so we end up getting a little bit of ghosting, and now we can do the ghosting on that. So let's go to, not snowfall, but ghost, there it is, and apply that. So we get a little bit of a motion trails from that, from these moving stars. And that will be the background into which we want our spaceship to dive. So let's go as soon as that's done. Yeah, this one's counting backwards. So we have, there you go, that was actually a little bit more than I thought we would need, but that's okay. Let's go with that, and then let's just enter the where is it, animation brush keyframer, and with the brush keyframer you get to see the animation and then see the custom brush on top of it, and because it's a custom animator brush, you'll see it cycle through its little motion that we have here. Now this one, the animation in the background is longer than the animation we still have in the custom brush, and that's why we see this little jump right here at the end. That's okay, we'll just crop that off at the end or clip it off. So let's say we want to have our spaceship initially big, kind of like this, but coming out of cloaking, so no, not the angle, but the opacity might be gone. And that's for the very first frame that we keyframe, and then we'll go here and bring the opacity to full opacity, but we also have the size reduced a little bit. There you go. And then here perhaps we'll have the angle a little bit like this, bring it down here, bring it a little bit smaller yet. That's that, and then go to another position where we have them over here, rotate them the other way, and something like this, keyframe that, and then at the end, just before we reach the end of our animation here, there you go, we'll kind of disappear, what's that, Mach speed, let's go dive right into the black hole here, so to speak. In fact, we might just have it zoom to 0 size or close enough. So at this point we have this animation where it's doing this, and the very end here we'll maybe just disappear on the opacity, and that's that, so we don't actually see the jump there either. Alright, so let's go render that, and here we go, we see the frame sequence being rendered with a lot of frames that we didn't have before. Right, keep that in mind. We are now actually using this sequence of frames that was initially only 30. We truncated some, we clipped some, and then in the end we actually now have a very much longer animation sequence, and that's what you can do with the motion prediction module to perhaps create a few more frames that you didn't have initially. Right, thanks for watching.